Afternoon. My name is Jim Prairie, and I work out of the Upper Colorado River Basin region of Reclamation. And today I'm going to be providing an overview of hydrology and operations in the Colorado River Basin and reflect on the 23-year drought that we've been experiencing since 2000 and the impacts we've seen in the basin due to that drought.
I'd like to begin looking at our long-term record from 1906 to 2020 in comparison to the recent 20-year period, the 2000 to 2020 millennial drought. When looking at the long-term period, we can see the natural flow averaged about 16 million acre feet, and flow is shown to the graph on the right in the blue line, while maximum use was 16.9 million acre feet. Use is shown by the orange line in the graph to the right. And we can see that over the 2000 to 2020 period, there was a significant change in this long-term natural flow versus long-term use. The long-term natural flow reduced to 13.4%, about a 20% reduction in flow over this 20-year period as compared to the previous 100-year period, 100-plus year period, while use has decreased slightly to 15 million acre feet, but not the same percentage as we've seen in natural flow. What we can see on the right-hand side is that use in about 2000 exceeds supply. We see supply dropping during the drought, and we simply use working to follow, but use consistently stays above. The final line shows the combined Powell and Meade storage. And we can see how the combined storage began filling in the 60s as Lake Powell was completed, and then went through a series of drops, the most significant in the beginning of 1999. And that's when we lost half our storage during a 5-year period that was the lowest 5 years we had on record. We've continued storage dropping since then with a little bit of ups and downs. And then the recent 3 years, we again have seen a period of 3 years well below average and a significant drop in storage, bringing us to where we are now. Next, I'd like to look at some of these changes in detail from the beginning of the drought to the end and where we have arrived.
This slide provides a view of the hydroclimatic conditions over the period 1981 to present in the Upper Colorado River Basin. It presents precipitation volume, temperature, natural flow, and runoff efficiency. And 4 lines are shown in each figure. The annual value is shown in the black line. The long-term average is shown as the dotted line. The 10-year moving average is the red line, and the linear trend is the dotted line. And that's the linear trend from 1980 to present. And what I'd like to bring your focus to is under precipitation. We're seeing a downward trend over this period, 1980 to present. Under temperature, we're seeing an increasing trend. It's a temperature increase of about 2 degrees over this period. And then natural flow resulting from both precipitation and temperature is showing a decline over this period. Predominantly, temperature increasing is impacting natural flow, though precipitation is secondly impacting it. And then runoff efficiency is a measure of natural flow over precipitation volume, and lets us see how much of the precipitation actually translates to flow. And we have been seeing a steady decrease in runoff efficiency as well, which again, we're attributing to temperature. The next slide is showing us a teacup diagram that gives us a picture of both Lake Powell and Lake Meade as we were entering the drought in December of 1999. So at this time when we entered the drought, we had just finished our work in signing the final surplus environmental impact statement that was filed December 8th, 2000. So we were at a point where we were very content to actually have finally in place criteria to deal with spills from Lake Meade, and had little idea of what was coming in the coming decades. In this figure, you can see at Lake Powell, we were at 88% full, and at Lake Meade, we were 96% full. So in a condition that was where you would ideally want to be seeing these reservoirs. This figure shows the Lake Powell unregulated inflow in the blue bar charts from 1999 through 2022. It also includes the 1991 through 2020 average annual inflow of 9.6 in the green dotted line, and then the 2000 through 2020 average annual flow of 8.62 in the orange dotted line. And I'll note that this 2000 through 2020 period of 8.62 is approximately 17% less than the long-term 1964 to 2020 average annual flow. The two other points I'd like to highlight is the 5-year period from 2000 to 2004. This is the lowest 5-year period on record, and it includes our lowest single year on record in 2002 of 28% of the 91 through 2020 average annual inflow. And then also at the end, we're looking at 2000 through 2022. These are 3 consecutive below average years, and what we see in the subsequent years will really dictate how far down Lake Powell and Lake Mead could continue to be drawn. So this next figure is looking at both Lake Powell and Lake Mead end of water storage. Lake Powell is shown in the gray above, Lake Mead in blue below, and we're looking at combined storage on the y-axis and the x-axis 1960 to 2022. Some of the key points here is in 1963, the combined storage was 17.9 million acre feet, or 34% of capacity, and this is as we began filling Lake Powell. In 1999, as I showed in the previous figure, we were fairly full in the system. We were actually 92% of capacity at a storage of 47.6 million acre feet. And then we had that 5-year period I highlighted, and that 5-year period had us drop over 50% of the storage that we saw beginning in 1999. And then we were able to weather with some ups and downs, but continuing drop in storage through to about 2000. And then in 2001, those 3 years we saw at the end, those resulted in another 50% drop of storage from where we were at the beginning of this period to end water year 2022 at 26% of capacity. So a marked reduction through this drought period. This figure here is showing the current storage volumes that we have in the system as of January 29th, 2023. So Lake Powell is presently at 23% of capacity, where it used to be at 88% in 1999, and Lake Mead is at 29% of capacity, where it used to be at 96% back in 1999. And the drop that we're seeing over this full period is a loss of about 32.6 million acre feet of water in the 2 reservoirs. At this time, we were 34 feet above min power pool. This red line here is minimum power pool at Lake Powell, and the red line at Lake Mead is min power pool at Lake Mead.
I'd like to conclude with this slide that was a joint effort between NIDIS and Reclamation. Both maps show a drought severity map overlaid with teacups from Reclamation's major reservoirs across the West. On the left-hand side, we're looking at September 18th, 2022. On the right-hand side, January 25th, 2023. And we're seeing the impacts of the recent rains that have been occurring on the West Coast. These rains have improved conditions in California significantly, and we're even seeing impacts on reservoirs in the California region. But when we look at the Colorado River Basin, we do see some improvement, but little change in the reservoir storage of Lakes Powell and Mead, shown in the bottom left, being the 2 largest reservoirs in the western U.S. I'd like to just emphasize that for Reclamation, these types of qualitative projects are useful just to see what's happening in the near term. You're looking out a few weeks. But our projections are reliant on forecasts that look out seasonally over months to a year to a few years. And developing products like this has been something that has not occurred yet through the NIDIS effort. If we had products that let us understand coming in of drought at a seasonal scale or out a year or two, that would be very beneficial for Reclamation's needs. Thank you.